In this video, I want to talk about how to match graphs with rational functions when they have two vertical asymptotes. So I'm going to start here with a function in its graph, and we're going to talk about features we're going to identify. And then we're going to move over to Alex and actually do a couple of problems. So to begin, this function is f of x equals negative x squared plus 2 over x minus 2x plus 1. And let's go ahead and try to figure out some of the features of this graph. So the first thing I'm going to look for is asymptotes. So the vertical asymptotes are going to be the things that make the bottom equal to 0. So x equals 2 and x equals negative 1. So x equals 2 is right here and x equals negative 1 is right here. Then the horizontal asymptote, so we have vertical asymptotes are x equals 2 and x equals negative 1. The horizontal asymptote is going to be what would happen if we divided the coefficients. So the leading coefficient of the top is negative 1, and the leading coefficient of the bottom, if you multiply it out, is going to be 1. So it's going to be negative 1 over 1, which is just negative 1. So the horizontal asymptote is y equals negative 1, and that's right here. So other things that we can look for are the y-intercept. So we can always look for the y-intercept. So if you plug in 0 for x, what does y equal? And here it's going to be 0, 0, 0. So it's going to be 2 over negative 2 times 1. So 2 over negative 2 is negative 1. So in this case, the y-intercept is 0, negative 1. And you can see that point right here. And you can also look for x-intercepts. So we can look for the x-intercepts. In this case, so the x-intercepts are where the top is equal to 0. So negative x squared plus 2 is equal to 0. We can move x squared to the other side, so x squared equals 2. So x equals plus or minus the square root of 2. So this is about 1.4, so plus and minus 1.4 are here, and here are plus and minus 1.4. And then we can look for different intervals where it's going to be positive and negative. So we can try to see where is the graph going to be positive and where is it going to be negative. So intervals positive or negative. So a rational function can change from positive to negative either at an x-intercept like this or at an asymptote like this. So it changes from positive to negative at an asymptote. So we can look at the intervals in between and see in between the asymptotes and the x-intercepts and see where is it going to be positive and where is it going to be negative. So for example, in this case, we can go from negative infinity to negative 1.41 something. That's the square root of 2. So in this interval, it's negative. We could find that out by testing a point like negative 2. So we could test a point like negative 2. It would be negative 4 plus 2. So the top is negative, this is negative, and this is negative. So that would make it a negative, and a negative would be negative. So this would be negative in this interval. Sometimes I like to draw a number line actually, so I can demonstrate that too. So we can draw a number line and say, okay, all the way up to negative 1.44. So this interval is negative right here. And then we want to go from 1.4 just to 1, to negative 1, because that's where the next place where it could possibly change is, because there's an asymptote there. So we can check a point in there. So you could check like 1.5 and see what it is, and it'll be positive. And then we can check in between 0 and 1. So we could check negative 0.5, for example. And negative 0.5 would make the top positive, this would be negative, and this would be positive. So it would be negative. And then we can check in between 0 and 1.4. So we could check 1, for example. So 1 would make the top positive, it would make this negative, and it would make this positive, so it would be negative. And then in between 1.4 and 2, and this isn't a great number line, but it doesn't really matter, we're just looking at the intervals. So in between 1.4 and 2, we could test 1.5, so that would be positive, negative, and, oh no, this would be positive, or sorry, this would be negative, and this would be negative, and this would be positive, so this would be positive. And then between 2 and infinity, it would be negative, positive, and positive, so it would be negative. And you can see that that follows what we have here. We have negative all the way up to negative 1.4, and then it's positive. Then it's negative from negative 1 to 0, it's still negative. And then we didn't even really need to put a point at 0 there. And then to 1.4, and then it's positive, and then it goes back to being negative. So those are the things that we're going to look for when we match a function to a graph of a rational function. So here's an example. It wants us to match f of x and g of x. So the first thing I actually want to do is factor these out. So this is going to be x minus, and sorry, I can't write on this screen, but we'll just talk it through. This is going to be x minus 2 times x plus 1, which is going to give me positive 2 and negative 1 as vertical asymptotes. So let's look at what has positive 2 and negative 1 as vertical asymptotes. And it looks like it's going to be these three here, A, D, and E, have positive 2 and negative 1 as vertical asymptotes. Okay, so now I can look at some of my positive and negative intervals. So let's first look at our horizontal asymptote. So the degree of the numerator is less than the degree of the denominator. The degree of the numerator in this case is 0, and the degree of the denominator is 2. So it's definitely going to 0 in its horizontal asymptote. So as x goes to infinity, we're definitely going to 0. So this graph D is out. So now to go between A and E, I can look at those intervals. So I actually see that these graphs are kind of the reverses of each other. So let's just look at what happens when x equals 0. So when x equals 0, it looks like we're at positive 3. And here it looks like we're at about negative 3. And here it looks like we're at about positive 3. So graph E is definitely going to be the one that we need for this first one, for f of x, is going to be graph E. Okay, now let's look at h of x. So h of x says it's 2x over x squared minus 2x minus 8. So if we factor the bottom, it's going to be x minus 4 times x minus 2, which gives us vertical asymptotes of positive 4 and negative 2. So that's going to be B, C, or F, one of these guys, because they all have those vertical asymptotes at negative 4 and positive 2. Now let's look at the horizontal asymptote. So the horizontal asymptote, we look at the degree of the numerator. So the degree of the numerator is less than the degree of the denominator, so that means that the horizontal asymptote is at 0. So that gives us B or F, not C. C doesn't work. So now that we have just B and F, we can kind of see what's different about these graphs and how can we test. So they both look like they go through 0, 0, so we can't test that. But we could test what happens at 2, for example, because here 2 is positive in graph F and 2 is negative in graph B. So let's just go ahead and do that. What's happening at 2? So positive on top, and then, let's see, 2 squared is 4, minus 2 times 2 is going to be 4, so it's going to be negative 8. So it's going to be a positive over a negative, which is negative. So graph B should be correct because 2 has a negative value. And so let's go ahead. Here 2 has a positive value, so that one's not going to be right. So we want graph B, and let's check that. Oh no. Oh no. It says that for f of x, my graph is incorrect. Let's see. Let's check 0 again. Oh, okay, I just made a mistake. So in 0, when I plugged in 0, probably because I can't write anything down on here, when I plugged in 0, I messed that up. So actually what it should be is it should be 6 when we plug in 0. So it was between graphs A and E. So when we plug in 6, or when we plug in 0 for x, it should be 6 over negative 2, which is negative 3. So that should be A. And let's recheck that. Okay, so let's try another one and hopefully I'll get this one right. All right, so in this first one, let's think about how we can factor the bottom. So the bottom is going to factor into x minus 4 times x plus 2. So that is going to give us asymptotes of negative 2 and 4, just like graph A has, graph B has, let's see, and graph F has. So negative 2 and 4 is going to be A, B, or F. Okay, now let's look at the horizontal asymptote. So it actually looks like they all have a horizontal asymptote at 0, that's what we have too, because the degree of the numerator is less than the degree of the denominator. So then we can let's look at the y-intercept. So in this case, if x is all 0, then the y-intercept is going to be negative 4 over negative 8, which is 1/2. So graph A has a negative 1/2, so that's not good. Graph B looks like it's negative 1, so that's not great. Graph F looks like it has a y-intercept of 1/2, so that looks good. So that seems to be the only one. So let's go ahead and try that one. Graph F. Okay. And then this one, if we factor the denominator, it's going to be x plus 3, or sorry, x plus 2 times x minus 1. Okay, so x plus 2 times x minus 1 means that we're going to have asymptotes at negative 2 and positive 1, and graphs D, E, and C all have that. They all have their horizontal asymptote at 0, which is the same as what we have here because the degree of the numerator is less than the degree of the denominator. And then let's look at the y-intercept again. That was helpful. So the y-intercept, if all the x's are 0, it's going to be negative 3 over 2, which is negative 1/2. So this one has an intercept at 0, 0, so that's not right. This one does look like negative 1/2, and this one looks like positive 1/2. So let's look, so this graph E, should be the only one that works. So, because that y-intercept is negative 3/2. Okay, so let's go ahead and check that one, and we'll hope we got it right. And that was right. Okay, so that is how you match graphs with rational functions that have 2 vertical asymptotes.